dark. Of course, we now know that the moon orbits Earth and they both orbit the sun. The dark side is merely a trick of perspective. The Apollo astronauts who went to the moon saw the other side and actually basked in the sunlight there. As it turns out, different parts of the moon are sunlit during different parts of each month, and not just one side. Its shape seems to change, which is what we call the phases of the moon. Interestingly, new moon, which is the time when the sun and moon are on the same side of Earth, is when the face we see from Earth actually is dark and the far side is brightly lit by the sun. So, calling the part that faces away from us as the dark side really is a mistake. So, what do we call that part of the moon we don't see each month? The better term to use is the far side. It makes perfect sense since it is the side farthest away from us. To understand, let's look more closely at its relationship to Earth. The moon orbits in such a way that one rotation takes just about the same length of time as it takes for it to orbit around Earth. That is, the moon spins on its own axis once during its orbit around our planet. That leaves one side is facing us during its orbit. The technical name for this spin-orbit lock is tidal locking. Of course, there is literally a dark side of the moon, but it's not always the same side. What is darkened depends on which phase of the moon we see. During a new moon, the moon lies between Earth and the sun. So, the side we normally see from here on Earth that's normally lit by the sun is in its shadow. Only when the moon is opposite from the sun do we see that part of the surface lit up. At that point, the far side is shadowed and is truly dark. The far side of the moon was once mysterious and hidden, but that all changed when the first images of its cratered surface were sent back by the USSR's Luna 3 mission in 1959. It's been more than 60 years since those first photos were returned to Earth. By current standards, they're rather poor images, but they were good enough to tell us that the far side of the moon was nothing like the near side. We got another stack of images of the lunar far side shortly afterwards, during the Apollo era, which was a product of a space race, which had been going on between the US and the Soviet Union. The two Cold War rivals were both determined to outdo the other and land humans on the lunar surface first. The US efforts in this contest included two predecessors to Project Apollo, Project Mercury, which began in 1958, and Project Gemini, which followed in 1961. But until the moon landing itself, the Soviet space program was ahead overall, with successful missions, including Sputnik, the first satellite to orbit Earth, and Luna 2, the first space probe to touch the moon. So, in 1961, President John F. Kennedy decided to take charge and propose to Congress the goal of landing a man on the moon and returning him safely to the Earth by the end of the decade. This seemingly impossible task quickly became the ultimate goal of the Apollo program, also known as Project Apollo. Kennedy's famous speech at Rice Stadium the next year inspired Americans to dream big. The announcement lit a fire under the teams at NASA to complete the task on a seemingly impossible timeline. But the ambitious goal required an equally ambitious budget. The US government ended up allocating $25 billion in 1960s dollars to the Apollo program, or about 2.5% of the US GDP at the time annually, for approximately 10 years. As such, the Apollo program, by far the most expensive spaceflight endeavor in history, kicked off that year, and by the time it ended in 1972, 9 missions and 24 astronauts had orbited or landed on the moon. Perhaps the most famous of those, Apollo 11, marked the first time humans had stepped on another world. On July 20th, 1969, Neil Armstrong and Edwin Buzz Aldrin touched down in the Sea of Tranquility in the lunar lander Eagle, while astronaut Michael Collins orbited the moon in the command module Columbia. Armstrong, who pressed the first boot prints into the moon's surface, famously said, "That's one small step for a man, one giant leap for mankind." The pair stayed on the moon's surface for 21 hours and 36 minutes before rendezvousing with Collins and heading back to Earth. Each mission after Apollo 11 set new milestones in space travel and lunar exploration. 4 months after the first humans reached the moon, Apollo 12 touched down, achieving a much more precise landing on the moon. Apollo 13 narrowly avoided a near disaster when onboard oxygen tanks exploded in April 1970, forcing the crew to abort a planned moon landing. All 3 survived. During the third lunar landing in January 1971, Apollo 14, Commander Alan Shepard set a new record for the farthest distance traveled on the moon, 9,000 feet. He even lobbed a few golf balls into a nearby crater with a makeshift 6-iron. Apollo 15, launched in July 1971, was the first of 3 missions capable of a longer stay on the moon. In the course of 3 days spent on the lunar surface, achievements included collecting hundreds of pounds of lunar samples and traveling more than 17 miles in the first piloted moon buggy. Apollo 16 and Apollo 17 in 1972 were the 2 most recent crewed missions to the moon, and Russia's Luna 24 crewless spacecraft in 1976 was the last to land until the following century. Samples collected during these lunar explorations produced huge amounts of knowledge about the geology and formation of the Earth's moon. After the dramatic accomplishments of the 1960s and 1970s, the major space agencies turned their attention elsewhere for several decades. So far, only 12 humans have set foot on the moon. However, during each Apollo missions, astronauts experienced strange phenomena that heightened the intrigue surrounding the moon. For instance, in Apollo 11 mission, on July 21, 1969, while Neil Armstrong and Buzz Aldrin made history by stepping onto the lunar surface, Michael Collins orbited alone in the command module. As Collins traveled behind the moon, he entered a period of complete isolation, cut off from all communication with Earth. During these 47 minutes, he reported hearing eerie, unexplained sounds through his headset. These sounds were unsettling and unlike anything encountered before. This was not an isolated incident. The Apollo 10 mission, which served as a dress rehearsal for the moon landing, also reported hearing similar mysterious sounds on the far side of the moon. NASA later attributed these noises to radio interference, but many astronauts were unconvinced by this explanation. The sounds, described as whistling space music, added to the growing list of peculiarities and raised further questions about the true nature of the moon. The astronauts' accounts fueled public speculation and conspiracy theories about what they might have encountered. Some believed these sounds indicated intelligent life or advanced technology on the moon. Despite NASA's attempts to explain away these anomalies, the eerie experiences of the Apollo astronauts continued to captivate imaginations and spark debates about what really lies on the moon's far side. A significant element fueling the mystery around the moon is the missing tapes and transcripts from the Apollo missions. While the world watched the moon landings in awe, crucial minutes of radio communication between the astronauts and NASA's mission control mysteriously vanished. These missing segments have led to rampant speculation about what might have been captured during those lost moments. According to unofficial transcripts, during these gaps, astronauts reported seeing strange objects and even claimed that they were being watched by unidentified entities. One notable incident involves Neil Armstrong and Buzz Aldrin, who allegedly saw UFOs lined up on the crater's edge. This startling claim, if true, would have been groundbreaking evidence of extraterrestrial presence on the moon. However, without the original recordings, it's challenging to verify these assertions. NASA has maintained that the tapes were either misplaced or recorded over, a convenient explanation that has done little to quell conspiracy theories. The idea of deliberate censorship by NASA gained traction when whistleblowers claimed that the space agency intentionally suppressed and sanitized evidence of extraterrestrial activity. The absence of these tapes has only deepened suspicions and has become a cornerstone for those convinced that the moon holds secrets far beyond human understanding. This controversy has kept the public questioning the true nature of the Apollo missions and what might have been discovered and hidden during humanity's first steps on the lunar surface. The mystery of the moon deepens with reports of UFO sightings by astronauts and the use of code words to describe these encounters. During the Apollo missions, astronauts often reported seeing unidentified flying objects, which they referred to using code names like bogey, Santa Claus, and fire. These terms were meant to keep their observations discreet, away from the public and media scrutiny. One of the earliest recorded UFO sightings in space came from Gemini 4 astronaut James McDivitt in 1965. He described seeing a strange object with arms protruding from it. But before he could capture a clear photograph, the sun's glare obstructed his view. This incident led NASA astronauts to develop code words to discuss such sightings without alarming the public or drawing undue attention. The Apollo 8 mission, which orbited the moon in 1968, is famously noted for its Christmas Eve broadcast, during which astronaut Jim Lovell reported seeing a Santa Claus, a veiled reference to a UFO. While NASA brushed off this comment as a joke, it fed into the growing speculation and conspiracy theories surrounding the moon missions. These sightings and the coded language used by astronauts suggest that there were more unexplained phenomena encountered during the lunar missions than what was publicly acknowledged. The consistent use of these codes indicates that such sightings were not isolated incidents, but a recognized and somewhat common occurrence among astronauts. This has left many to wonder what other secrets and anomalies were observed but never disclosed, further entrenching the belief in a covert extraterrestrial presence on or around the moon. The testimonies of whistleblowers have added a dramatic layer to the mystery of the moon, bringing claims of secret moon bases and alien structures into the spotlight. Among the most prominent whistleblowers is Sergeant Carl Wolf, who worked at NASA's Lunar Orbiter project in 1965. Wolf claimed that he was shown photographs of structures on the far side of the moon, including towers, spherical buildings, and mushroom-shaped constructs. According to Wolf, these images clearly depicted artificial creations, suggesting the presence of an advanced civilization on the moon. Another key figure is Dr. Ken Johnston, a former NASA aerospace engineer who worked in the Lunar Receiving Laboratory during the Apollo missions. Johnston claimed to have seen photographs of ancient alien cities and machinery on the lunar surface. When asked to destroy these images, he instead kept a set, which he later revealed to the public. His disclosures, however, led to his dismissal from NASA and cast him into the realm of conspiracy theories. Donna Hare, another NASA contractor, supported these claims, stating that NASA routinely airbrushed out UFOs and other anomalies from lunar photographs before releasing them to the public. She recounted an incident where a technician pointed out a round shadow on a photo, indicating a UFO had been deliberately erased from the image. These whistleblowers faced significant professional and personal risks by coming forward. Their stories have been met with skepticism and scrutiny, but they continue to resonate with those who believe in extraterrestrial activity on the moon. The allegations of a cover-up, combined with these dramatic accounts, suggest that the moon harbors more secrets than the public has been allowed to know, perpetuating the allure and enigma of lunar exploration. The deaths of whistleblowers have further fueled suspicions of a cover-up regarding lunar anomalies and extraterrestrial activities. Sergeant Carl Wolf's tragic end came in 2018 when he was hit by a truck while cycling, a death that many conspiracy theorists find suspicious, given his revelations about secret moon bases. Wolf had boldly stated his willingness to testify before Congress under oath about what he had seen, but his untimely death prevented him from doing so, leaving his claims shrouded in mystery. Dr. Ken Johnston also faced significant backlash after revealing photographs of alien structures on the moon. Despite his dismissal from NASA, He continued to advocate for transparency about what he believed were clear signs of extraterrestrial presence on the lunar surface. Although he didn't face a mysterious death like Wolf, his professional reputation was significantly tarnished, and he became a marginalized figure within the scientific community. These whistleblowers were not alone. Donna Hare, who claimed NASA airbrushed UFOs from lunar photographs, also faced intense scrutiny and skepticism. Her assertions about sanitized images highlighted the lengths to which she believed NASA would go to hide evidence of extraterrestrial encounters. Despite the lack of physical evidence, her testimony contributed to the narrative of a deliberate cover-up. The deaths and discrediting of these whistleblowers underscore the risks faced by those challenging official narratives. Their accounts, whether wholly accurate or not, have added layers of intrigue and suspicion to the story of lunar exploration. Many believe that these individuals were silenced or discredited to prevent the truth from coming out, perpetuating the idea that there are significant, undisclosed mysteries about the moon that authorities are determined to keep hidden. Today, modern lunar anomalies continue to intrigue and fuel speculation about what might be hidden on the moon's surface. With advancements in technology and renewed interest in lunar exploration, numerous images and reports have emerged showing strange, unexplained features. One of the most notable cases is the 1994 Clementine orbiter mission, which took millions of images of the moon. Upon release, many of these images appeared to have sections blurred out, suggesting deliberate censorship. The so-called Zan object in the Zonde crater is a prime example, where overlapping and enhancing images revealed what seemed to be a large, possibly artificial structure. Other anomalies include what look like giant footprints, pyramids, obelisks, and mile-high towers scattered across the lunar surface. Scientists have attempted to explain these features as natural formations, such as meteor impacts, but the uniformity and scale of some of these structures challenge these explanations. For instance, the Mystery Hut, photographed by China's Yutu-2 rover in 2021, sparked a global buzz, though it was later identified as a rock formation. Moreover, images from various lunar missions show peculiar shapes and alignments that don't fit natural patterns, such as the uniformly deep craters and geometric structures. The blurred-out sections and anomalies have led to widespread speculation about what might be hidden. Some believe these features could be remnants of ancient alien civilizations or even operational extraterrestrial bases. NASA's explanations, often attributing these phenomena to tricks of light or pareidolia, the human tendency to see familiar shapes in random patterns, haven't satisfied everyone. The deliberate blurring of images, coupled with historical claims of whistleblowers, keeps the intrigue alive. As more countries and private companies prepare for lunar missions, there is hope that new explorations will provide clearer answers. Until then, the moon remains a focal point of mystery, with many convinced that its secrets are waiting to be uncovered. The renewed interest in lunar exploration marks a new era of discovery and potential revelation of the moon's secrets. After a long hiatus since the Apollo missions, numerous countries and private companies are setting their sights on the moon. This renewed effort is driven by advancements in technology, a desire for scientific knowledge, and potential economic opportunities. In recent years, China has made significant strides with its Chang'e missions. In 2020, the Chang'e 5 mission successfully brought back samples from the moon, while the Yutu-2 rover continues to explore the moon's far side, capturing intriguing images, including the Mystery Hut. The United States, through NASA's Artemis program, plans to return astronauts to the lunar surface by 2026, aiming to establish a sustainable human presence and explore the lunar South Pole. These missions aim to uncover new scientific data and test technologies for future Mars missions. India's Chandrayaan-2, Russia's Luna 25, and Japan's SLIM mission are also part of this renewed interest. Additionally, private companies like SpaceX, Blue Origin, and Firefly are developing their lunar missions, with goals ranging from lunar tourism to mining resources. This resurgence in lunar exploration is not just about national pride or scientific curiosity. There is a growing belief that the moon holds valuable resources, such as helium-3, which could be used for future energy production. Furthermore, establishing a presence on the moon is seen as a stepping stone for deeper space exploration, including missions to Mars. As these missions progress, there is hope that they will also address some of the long-standing mysteries and anomalies that have fueled conspiracy theories for decades. The influx of new data and images from diverse sources may either confirm or debunk the theories of alien structures and hidden bases on the moon. With multiple players involved, the next decade promises to be a period of unprecedented lunar activity, potentially unraveling the secrets that have long eluded us, and possibly confirming whether the moon is just a barren satellite or a repository of extraordinary discoveries. In addition, note that the potential science from future lunar mission stretches far beyond the moon. Scientists believe that a new radio telescope on the far side of the moon could capitalize on NASA's new Artemis era of lunar exploration to potentially probe deeper into the universe than even the newly operational James Webb Space Telescope can. A proposal for a lunar telescope named Farside, led by Jack Burns of the University of Colorado Boulder, was submitted as a potential probe-class mission costing $1 billion to $2 billion. Burns has been working on a plan for a radio telescope on the moon since the 1980s, but ultimately Farside wasn't selected for recommendation by the Decadal Survey. However, a brand new concept is now being evaluated called the Lunar Crater Radio Telescope, which is led by robotics technologist Saptarshi Bandyopadhyay of NASA's Jet Propulsion Laboratory in California. It would be a 350-meter diameter radio telescope in a 1.3-kilometer wide crater on the far side of the moon. The original plan was for an even larger telescope, 1 kilometer in size, but the sheer scale of that instrument proved unfeasible because of the total mass that would need to be launched from Earth. Fortunately, as we looked at the science, we realized that a diameter of 350 meters would be sufficient to give us the science that we want to get. That science involves seeing back in time to a distant era known as the Epoch of Ryanization. Shortly after the Big Bang, there were no stars and galaxies, only a vast fog of neutral hydrogen. This period has been dubbed the Cosmic Dark Ages. Eventually, the hydrogen began coalescing to form stars and galaxies, lighting up the universe and ionizing the neutral hydrogen. It is this early era that the Lunar Crater Radio Telescope would hope to see. Ordinarily, neutral hydrogen emits radio waves at a wavelength of 21 centimeters, but cosmic expansion will have lengthened the wavelength of the radio waves emitted by hydrogen in the dark ages to extremely long wavelengths of tens of meters. Detecting this long wavelength light on Earth is difficult, partly because the ionosphere, the upper realm of our atmosphere, can reflect light of these wavelengths back into space, and partly because terrestrial radio interference can obscure it. The thing to do would be to build a giant radio telescope on the far side of the moon where there is no ionosphere, and where the moon itself can shield the telescope from interference from Earth. Bandyopadhyay's plan is to send a spacecraft to a suitable crater on the lunar far side. The spacecraft would land inside the crater and then fire multiple cables with anchors into the rim of the crater, where the anchors would penetrate securely into the lunar regolith. The cables would then pull tight, creating a framework to hold the wire mesh radio dish, which would be folded like origami into the lander and open as the cables pull taut. A feed antenna would be deployed above the dish, and a spacecraft overhead would first provide a beacon signal to help calibrate the telescope, and then act as a relay for data and commands, since Earth cannot be seen from the lunar far side, hidden as it is behind the body of the moon. At least that's the plan. The Lunar Crater Radio Telescope is currently in Phase 2 of NASA's Innovative Advanced Concepts Development Program. through which it has received $500,000 of funding for maturing the necessary technology. But that's a far cry from the multi-billion-dollar budget that would be required to make the telescope mission a success. Because of the hefty price tag, the telescope requires strong support from the scientific community to win a recommendation in the next decadal survey. Fortunately, there may be another option, suggested Stephen Kahn, a physicist at Stanford University in California who is not directly involved with the project, in that it dovetails with NASA's desire to do more exploration on the moon. There are programmatic reasons to want to do more frequent flights to the moon, and so the hope is to try and capitalize on that, he said. This approach is embodied in NASA's Commercial Lunar Payload Services program, which will see more than 50 small science payloads be delivered to the moon by private contractors over the next 3 years. 3 of these payloads will head to the 312-kilometer-wide Schrödinger crater, which is an impact basin on the far side of the moon near the lunar South Pole, in 2025 on a lunar lander built by the Massachusetts-based aerospace company Draper. Schrödinger is an interesting target and is thought to be the second youngest impact basin on the moon. The 3 payloads, named the Farside Seismic Suite, or FSS, the Lunar Interior Temperature and Materials Suite, or LITMS, and the Lunar Surface. Electromagnetics Experiment, or LUCI, will investigate the relationship between the formation and size of the crater, as well as the interior structure of the moon. According to Needham, the impact that formed Schrödinger was so large that we think it penetrated all the way through the moon's upper crust and into the mantle. Exploring that will be really important in helping us understand the bulk chemistry of the moon, what the moon is made from inside and out, and how that helps us understand how the moon formed and how it cooled off from its hottest, earliest days when it was volcanically active and a much more dynamic place than it is today. For example, the seismometers will listen for moonquakes caused by meteorite impacts or by the strain on the moon's interior, caused by gravitational tides emanating from Earth. As the seismic tremors reverberate through the moon's interior, the signal that FSS will detect can tell scientists about the structure, composition, and density of the moon's interior. Meanwhile, the LITMS experiment is armed with a heat flow probe with which it will be able to take the internal temperature of the moon for further details about the interior of the moon. The final experiment, LUCI, will study dust in the moon's exosphere, which is the thin layer of gas and dust that clings close to the surface and is sputtered off the ground by micrometeorite impacts and electrostatic forces. Together, this trio of small robotic experiments could pave the way for further exploration of the far side. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.